This video contains the solutions to take-home problems number 13. For this first one, we have an equation where the left-hand side is factored and the right-hand side equals 0. Now that 0 is really important because we have a special property that 0 has, which is that when you have several things multiplied together equaling 0, one of those things has to be 0. So either this first thing is 0, or the second thing is 0, or this third thing is 0, or this last thing is 0. And that's going to give us several solutions to this equation. Now for the first one, of course 4 does not equal 0, so that doesn't give us a solution. But in the next one, if we add 5 to both sides, we get a solution x equals 5. Next, if we subtract 3 from both sides, and then divide both sides by 2, we get another solution, x equals -3/2. And then finally we get another solution, x equals 7. So we have 3 solutions here. Sometimes we'll write this in the form where we say that the solution set is the set containing these 3 numbers. So we write squiggly brackets, and then we just list the numbers separated by commas. The order doesn't matter, we just list all the numbers that we got solutions. If we ever get the same solution multiple times, we only list it once. So here we have an equation where we don't have the situation before. We don't have a factored expression on the one side and a 0 on the other side. But we'd like to try to get that if we can. So first thing we need to do is get a 0. So let's subtract the 7x and the 18 from both sides. That's going to give us x squared minus 7x minus 18 equals 0. Now since what we have here is a trinomial, and we have the coefficient of x squared being 1, we should at least think about trying to factor this. And if we think a little bit about different ways that we can factor 18, so we're looking for two numbers that multiply to be 18, where their difference is 7. And that is going to be 9 and 2. And the difference between 9 and 2 is 7. Since the 7 is negative, we want the bigger number to be negative and the smaller number to be positive. So there's our factored expression. And that gives us 2 solutions, either x minus 9 equals 0 or x plus 2 equals 0. So x equals 9 or x equals -2. Here we have a situation where the left-hand side is the square of an expression. And so what we can do is use the square root method. So if we take the square root of both sides, what we end up with is that x minus 4 equals plus or minus the square root of 25, which is 5. That gives us 2 equations. One where x minus 4 equals the positive 5, and one where x minus 4 equals -5. Here if we add 4 to both sides, we get x equals 9. Here we add 4 to both sides, we get x equals -1. So there are our 2 solutions. So here again, we don't have a 0 on one side of our equation, so we're going to move everything over to one side. So we get 10x squared minus 21x minus 10 equals 0. And now it's possible that this might factor, but the fact that we have a 10 in front of our x squared is going to make factoring this quite difficult. So my advice in these situations is to not even try to factor it, just go ahead and use the quadratic formula. So the quadratic formula tells us that our solutions are x equals minus b plus or minus b squared minus 4ac all over 2a. So the b is -21, so we get minus 21 plus or minus 21 squared minus 4 times a, which is 10, times c, which is -10. All divided by 2a, so 2 times 10. Again, my advice here is not to try to plug all of this stuff all into your calculator all at once. It's really easy to run into problems where you get errors and mistakes if you try to do this all at once. So let's just leave it the way it is and try to work out each individual piece. So minus 21 gives us 21. Let's figure out what's inside that square root now. So again, using our calculator, -21 squared is 441. And then minus 4 times 10 times minus 10 is going to be plus 400. So that gives us 21 plus or minus the square root of 841, all divided by 20. And it turns out that the square root of 841 is 29. So we get 21 plus or minus 29 over 20. So that gives us 2 answers, 21 plus 29 over 20, and 21 minus 29 divided by 20. 21 plus 29 is 50, so we get 50 over 20, which works out to be 5/2. And 21 minus 29, that's -8 over 20, which reduces down to be negative 2/5. So we get two solutions, 5 over 2 and negative 2 over 5. All right, finally we have an equation that doesn't really look much like the equations that we've been working with, but if we work the way we normally would to get rid of these fractions, we'll see that it's the same kind of quadratic equation we've been talking about. So if I want to get rid of these fractions, what I'd like to do is take both sides of this equation and multiply by a common denominator. So since my denominators are x minus 3 and x, the common denominator I'm going to multiply is just going to be x minus 3 times x. Now on the left-hand side, I have to make sure to distribute. Don't just start crossing stuff out. Do your distribution first. So we end up with x minus 3 times x times the fraction 2x divided by x minus 3, and then plus x minus 3 times the fraction of 1 over x. This x minus 3 is going to divide out with that x minus 3. This x divides out with that x. And then on the right-hand side, we can just multiply this out. We end up with 4x squared minus 12x. On the left, we have x times 2x and x minus 3 times 1. And we still have 4x squared minus 12x on the right. That gives us 2x squared plus x minus 3 equals 4x squared minus 12x. As usual, we want to move everything to one side, so let's subtract 4x squared from both sides and subtract 12x from both sides. And we get negative 2x squared minus 11x minus 3 equals 0. And again at this point, since the coefficient of our x squared is not 1, I'm not even going to try to factor this. I'm just going to go straight to the quadratic formula. That's going to look like this. This is the equation we're trying to solve. Our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So my b is negative 11, so negative b is minus 11. B squared is minus 11 squared, minus 4 times a, which is negative 2, times c, which is negative 3. All divided by 2a, so that's 2 times negative 2. So this is 11 plus or minus. Now inside that square root, we're going to end up with 97, and then a negative 4 on the bottom. Now 97 doesn't have a nice square root, so we're just going to leave it as square root of 97. So this gives us two answers, 11 plus the square root of 97 over negative 4, and 11 minus the square root of 97 divided by negative 4. Now, we typically don't like having a negative denominator like that, so I'm just going to multiply top and bottom by negative 1 for both of these. So the way that I would typically write these numbers is as negative 11 minus 97 divided by positive 4, and then negative 11 plus the square root of 97 divided by positive 4. That's just a sort of more typical way that we would write these.